2 and case C3, I have to code this in else part. So let's do that. So what we do is we'll write a loop where I runs from front to I less than max I plus plus. Here I'll write printf percentile d q of I. After completing one half, again I'll start from I is equal to 0 and I should be less than rear I plus plus q of I. Okay. Let's see it's working or not. Okay. I want to enqueue an element. Okay. What is the size? We'll check once. Okay, size is 5, no props. So I'll do 1 addition, again addition, again addition, again addition, 5. Again I want to enqueue, it's giving me queue is full. Okay. So this earlier was case A, now we are in case B now. Okay. Now I want to do deletion. When I do deletion, so we did one mistake. 1 minute, just close it. After deleting, we have to decrement the count also here. We didn't do that actually. Count when we delete an element, yeah. Otherwise, the logic doesn't works. Count minus minus. Okay. So adding an element. Queue is full. So I want to see the elements. Yeah, 1, 2, 3, 4, 5. These are the elements. Okay. Now I want to remove an element first. So 1 is deleted. So when 1 is deleted, again I want to delete an element. 2 is also deleted. Now I want to this is case 2. Okay, I want to display elements. Yeah, this is case 2, case C2. This is case C2. Right? I would able to display 3, 4, 5. Now, what do we do is again I would like to delete 2 more elements. Okay, yeah, I would like to delete 2 more elements. Again, I display. I have only 5. Okay, so to which f is pointing to, and again I will insert 1 more element, which is 6. Yeah. So see, display should have 5 and 6, of course. So it has 5 and 6. Okay. So our logic is working fine. Okay. So this is how circular queue is implemented. Now there is another version of queue which is called DQ, is of our interest. So let's talk about what is DQ. So far we have seen stack, queue, simple queue, circular queue. Now we are going to see DQ. Okay. On stack, what are the attributes we use? Top. Here we will use front, rear. Here also we will use front and rear. In DQ also we will use front, rear. What are the operations can be performed? Push, pop, peek, display. Here operations can be performed on NQ, DQ, display. Here also what operations can be performed is NQ, DQ, display. As in a special case, it takes a lot of work factor in moving sliding elements into an array. It simplifies this problem. Okay, so this is relatively efficient. Than simple queue. Okay. Now in DQ, what is DQ actually? DQ is a linear data structure which supports operations on both ends. For example, here it supports these operations only at one end. It supports operation only at one end. That is, push and pop, all these operations can be performed only from one end. You cannot perform from other end. As I have told you, it's an open pipe. So operations can be performed from open end of a pipe. Now, what is queue? In queue, queue is a data structure in which operations can be performed. Operations can be performed at both ends, but restrictions are there. Okay, input only from rear end, output or delete. Input is nothing but we call it as adding, NQ. NQ is performed only at rear end, and DQ is performed only at front end. Okay. In circular queue also same. At rear end, NQ can be performed, DQ, removing of elements can be performed at front end. So DQ is a structure in which operations are performed like insert or delete, that is NQ or DQ, but these operations are not limited to at any one side. NQ and DQ can also be performed on DQs, but at two different sides. It means at rear end, I can perform both NQ and also DQ. Okay, insert or delete is also possible. So I call here NQ as insert, DQ as delete, DQ. Okay, at rear end, I can perform both NQ and DQ, and at front end also, I can perform NQ and also I can perform DQ. Okay. Now, the concept of count, which we have seen in circular queue, will help a lot in doing that. But of course, this concept of count doesn't work in linked list representations. There we have to find out these boundary conditions in terms of front and rear only. Okay. So this you try out and come up with the solutions. However, we'll see in the next session how to implement this.